Is yes, it is started the recording. Hey, good morning. Thanks for joining the session. This is Swami. I am recording the session. Let me share my screen and the entire screen. Okay, so please do let me know if you are able to see my screen.
Yes, I'm able to see.
Okay, cool. Thanks. So these sessions are being conducted from Microsoft's Learn community, uh, MSFT Learn community. These are learning rooms, and my learning room is Swami the Learner. So this is about the microservice series. So let me come, and this is an introduction section.
Okay.
So it is a very long 120 episodes. I'm going to give the details. Before that, first let me give my GitHub
Okay,
URL.
sure.
Okay, so you can call me Swami.
Oh,
So
thank
so that so others who will come, they will be benefited. Either they're watching the recording or so. This is the organization where we will have everything. So this organization, Vishwanath Swami PK Tech Skills Academy. So this is the organization which we will be using it for this entire series. And
you.
the events will be published at two places. One is in the Microsoft Learning Room here. I'll publish it here, as well as I'll be publishing in this in my meetup group as this one. So I saw 39 people RSVP, but only one is online, but we will go ahead. And another important thing is all the videos will be published here. So I'll give you all the stream link also, the video link also, subscribe to this. Okay, those are the details. Now let's come back to this series. What is this microservice series? So before this also, I did couple of microservice series, but I'll just wanted to show you that and then set the context. If you see, there's a similar microservice series which we did it technically. Johnny, Robbie, Swami, we three people did this series, and this series was directly we went into the web API and created the workflows and CI/CD, the infrastructure, everything we did from there. So I just want to show you that just to set the context. If I come into this shop main, here is a repository. So we will be doing the similar concept, not very similar concept, but not exactly this, whatever we did it 2 years ago. So we'll be building an entire microservice application and host it in two different cloud, one in Azure, one in AWS. So the entire solution will be deployed in two different places. So how this series, whatever we are planning now, is different from the existing series which we did it. And also I did some bits and pieces here and there in different communities. So how is this different? So this directly started with creating a microservice and going ahead and deploying it and accessing it from Kubernetes, everything. It has got their independent repository. Infrastructure is getting created through IaaS, infrastructure as a service. And if you see that, the infrastructure, it has got Terraform, AKS, and to deploy you have YAML files and you have Docker Compose, and we have workflows. Everything was there. But the assumption was that the folks who are joining this series, they already know most of the things. That means what is Web API or a REST API, what is MongoDB, how the communication happens, how and what is infrastructure as a code, Terraform. That's the assumption. So this series, whatever I'm going to start now, is going to span across 2 to 3 years a minimum, 120 episodes. How this series is different. So if we come to the main repository, if we come to the main repository of this, here the main repository, this is where every piece of documentation, other important things will come in. All the resources will be here. Suppose if you have to create some infrastructure or anything, instead of spanning it across different repositories, I'm going to store it here. All the scripts, maybe PowerShell scripts or shell scripts, everything will be stored here. Okay, so I will explain the high level agenda. So the first thing is prerequisites, the box setup. We'll see that in a minute. So if you see this organization where we'll be creating lots and lots of repositories, and all the things we used to do in Azure DevOps, we'll be doing here. That means we will create a projects here, and you will have the swim lanes, the board, the backlog ready, whatever we used to do. That's one thing. And we will maintain our own packages here, the NuGet packages or NPM packages. We might target the Docker container also, at least from the packages perspective, I'm sure we are going to store. And we'll be having different repositories, purely the microservice. Each of the things will have its own repositories, its own CI/CD pipeline, build pipeline, everything. Its own. That's one plan. And another thing is, if we come and see here, first let me walk you through the agenda. I'm not sure whether people will like this agenda or not, but this is what I'm planning. So what is the first thing we will do is we will speak about the setup of the box, but I have two choices. One, if you guys have documented that, if you guys want to go ahead and look at the documentation and set up your dev box, I'm fine with that. Else, if you want me to assist in that, that also I'm open for that. So we will discuss and we'll go for voting at the end of this session. So first thing is, we'll think of crossing the river when the river comes. So as of for the first set of topics, whatever we discuss, this will be, I'll come back. So if you see here, the first agenda is, if I'm directly starting either the API or something with C# or Go language or Python or Java, or whatever the language it is, people might understand it or people might not understand. So this is what I thought. So let's take 10 hours or 6 hours or a mix of hours. Let's start something and again we'll revisit that. So that means first, if we see, we'll discuss C# crash course for 8 hours. And I want to give you that .NET is if you see this life cycle and why is that we are learning .NET, you will get this in this picture. You'll get this in this picture. Now, if you see that the .NET 6, its end of the life is November 2024, and .NET 7, it's May 2024. So .NET 8 is the one which is going to release. So this is the one, .NET 8, and that's a long-term support. So patches for 36 months. So that means if we learn .NET, so we are somewhere here. By the time November comes, we'll be learning, because we'll directly jump and start learning things from basics in .NET 8, not in .NET 6, directly in .NET 8. The advantage of learning that is, if we learn .NET 8, we are here, July, August, September, October, November, 5 months. So decently we will cover enough subject on .NET 8, C# at least. So from there, this will go for 36 months. That means 3 years. So if you learn .NET 8 in this 5 months, so you are secured for 3 years. Like if you see that .NET 6, if someone would have learned .NET 6 by 2021 or early 2022, they are good till November 2024 for 3 years. So similarly, now we are starting on .NET 8. That means we'll be very good for next 3 years. So 2024, 25, and till November 26, and above also, I don't know. But at least minimum until this .NET 8 spans for 36 months. So we are good. And then we can learn .NET 10. We are 2 years old in .NET 8. .NET 9 is the standard term support, which is for 18 months. And immediately we need to, even if you write something, we need to rewrite in the next .NET 10. So what we will do is we'll start with .NET 8 and we'll learn this one. And how do we learn these things? So if you see topic 1, the C# crash course, I would just like to give that. I'm holding on that. So to learn C#, what is important? So the first thing is we need to have a PowerShell core or above. And how do we install and check the version check? And we'll install the SDKs 6, 7, and 8. I've given that. And how can we check it? And we will install the Visual Studio. Then we will install a couple of extensions. As of now, it's like just enough infrastructure what is needed, or just enough software and tools what is needed for us to continue with the first 10 hours of training. So those tools, and we'll install the Windows terminal. The advantage is you can have the PowerShell core or the Git bash or command line or PowerShell or .NET developer, anything you can open it here. Then we'll install Git for Windows and install GitHub Desktop. So these are the prerequisites for the first course. So the first one is C# crash course. A minimum 10 sessions is what I'm expecting. So in this 10 sessions, what we will be doing is we'll start with starting. Like what is .NET and .NET's history, and few points about the C#, like but it's a multi-paradigm programming language, and each of the program will have an entry point. That's a program class and should have a main method, which is an entry point. Few details we'll speak about that. And then we'll discuss like how many ways you can create. Mostly will depend on Visual Studio Code and SDKs, because Visual Studio license, some people might have, some people might not have that. But we will use Visual Studio Code. I've gathered all the commands, but I'm just giving you, still this documentation is work in progress. I'm explaining what will happen. So we'll see that how do you use the program top level statements and how do you use without top level statement. So we spoke that every executable should have a program class. But here in this top level statements, we don't see the program class, but still behind the scene, if you go and see, the compiler itself will generate a program.cs, whereas here you see the program class here and a main method. So these two are definitely needed as an entry point. But here in the top level statements, you have one line. You don't see the program class and you don't see the main method, but compiler will create behind the scene. How does it create? Where does it store? We'll dig that deep. And also we'll see that what is intermediate language. That means you have the C# program that gets compiled from using the compiler. It gets compiled into intermediate language. Previously we used to call MSIL. Now generically it's being called as intermediate language. How does the intermediate language look? We'll dig deeper into that. And then it gets JIT compiled. And we'll also dig deeper into that. Where can we find this class? And I want to show you a few other things here. Like if you see, we have just seen that. And in how many ways you can creating a console application within an existing folder or a new folder. And then if you want to see what is the compiler version and the language C#11 we are using and the compiler version, how do you see that? And how do you create console application with different command lines? Okay, and what is this global JSON? Why do you need global JSON when you have a lot of SDKs installed? Which version you want to target? So like this, slowly we'll take it up. Okay, so in this exercise, the first exercise, we'll be doing this. We'll go for routing, whether you guys will go ahead and read the documentation and get your box up and running. I'm fine with that. Else you want a 30 minutes as a office hours where we go and install these required software and tools and extensions, whatever we call. We will go and deploy and install and make your dev box ready. We'll make it. All the tools which we'll be using will be open source. Just to avoid the licensing issue, everything like that is the reason I'm mainly targeting VS Code and SDKs. And Visual Studio Community Edition is there. Again, we need to go through those licensing and all those things. I don't know whether we qualify to that or not. Just to be on a safer side, we'll use all the open source tool. So coming back to bulleted point 2, what is that we will be learning in the second bulleted point, C# crash course. So C# is a big ocean. It's a big ocean. So what we will be doing is just enough things for us to walk. So we'll learn, we can put in a max of 10 to 12 hours. I'm capping it to 10 hours, a decent 10 hours, where we learn some of the fundamentals of the C# programming, including reading an XML or reading a JSON, file reading kind of things, like fundamentals of that. What is MSL and conditional statements and looping and few other struct and record and few data types, and all the way till reading something. We'll not discuss anything on class in that second bulleted point. We'll just discuss just enough fundamentals, because what happens is, if you have seen the software release lifecycle before and now, previously when some software has to release, it used to take 5 to 6 years. Then later they made it like 4 years, then 3 years, then 2 years. Now, if you see .NET, they're releasing every 1 year. And if you see Angular, they release every 6 months. And also the support for the previous version will be for a defined period. It's not unlimited talk time offer. It's like a defined. So we have seen it. Like the standard time support is 18 months and the long-term support are 36 months. So even if you learn .NET 8, you're securing yourself till 2026. Then after 2026, when the support dies, still the project will remain. But until unless you hit a roadblock, you have to migrate it. But the good thing is, as soon as a new version, new long-term support version comes, it makes sense to move because there will be a lot of constructs and there'll be a lot of improvements in every new version. I just wanted to show you one difference here. If we just give me 1 minute, let me go and take this up. And if you see this one, I just wanted to show you a few things. Like you see, this will be the program which we will be discussing in our day one. So this is a traditional uh, programming method way we used to do it. And we used to write these comments and then we'll have a using statements. Then we have a namespace, double mustache, and we have a class program and we have two mustaches. We have static program, we have two mustaches, and we'll write the code. And this is how it used to be. Now, if you come and see, this is being done in 46 lines. Like if you come to the top level constructs, the same thing is being done in 16 lines. On top of that, the performance is a bonus for us. So like this, it's good. We'll learn the latest .NET 8 and a bit of C#, like just enough C# for us to move further. And like this, we'll learn like what is the primitive data types, what is variable, so name, memory location where you'll store and where you can modify what is the min and max of these data types. We'll be seeing this. And also I told one thing, for every program, there should be a program class and a static main method. These two are definitely needed as an entry point. But as I was mentioning, when it comes to top level statement, we don't have, then who is that who is creating it? So I'll show you. When we go and dig deeper into the debug and open this, it decompiles. And when I expand, you can see that the program class here. So the compiler itself is generating. That's what I've shown in the documentation. So we'll go deep into the weeds to find out some of these things. Not in all programs, but somewhere we need to know more fundamentals, because when we are setting the context, we said that the program class and the main method is needed. But when we go and start using the top level statements, nowhere we are seeing it. No need to worry. The compiler is creating it for us. So that's what we wanted to learn, and we will definitely learn those kind of nuts and bolts for sure. See this is the main method. Go the program class. You see that the compiler generated. So we'll do this one. So what is that we are going to do again is we'll learn just enough C# for 10 hours, C# 8 to be specific. I'll exclude this is work in progress. And then we'll learn a bit of object-oriented programming. We will not discuss anything on class or anything there. It's just like if conditions, for loops, and what is compilation. We'll go and look into that MSIL. That means I'll come in IL ESM. Oh, sorry for that. I should switch it to this one. It's my mistake. Okay, so we'll load it. Never mind. We'll load it. We'll go here and copy the path. This one. Now see this. The program, the top level statement program. What is that here? The first line is it's printing hello world.net. So I'll put side by side. And hello. Okay, so let's put this side by side and we'll see. I come into this program class. Okay, inside the main method, you see that here is the intermediate language. So the program class or the entire program will get compiled into intermediate language, IL, you see that. So load string. So that's what it's loading this hello world.net over here. And then it is invoking a method call. It's invoking a method called writeLine with the string which it created. So console.writeLine hello world.net 8. So it's being done here. So there is no operation after that. Then it's calling another method, int method. It's passing two values, 2 and 4. Like this, we'll do a little bit of deep dives under the hoods. What is happening? We'll do not all the time, but wherever we'll get a chance, we'll do a decent deep dive and go and find out what is happening under the hoods. And we'll learn those nuts and bolts. So the first thing is point 2 and point 3 is we'll start with just enough object-oriented programming. Okay, what is class, inheritance, and something about visibility, and those kind of things. We can cap it like not more than 6 to 10 hours. Let's cap it that way. The thing is that we are introducing C# into, but we are not abandoning it. We are learning for 6 to 10 hours. And again, we'll come to the next topic and we will learn few other things because we're not speaking anything about class and other things in the section 2 that we are speaking in section 3. And in section 3, we'll cap it 6 hours or 8 hours or 10 hours, max 10 hours. We'll not overkill ourselves. We'll learn just enough. We'll think of crossing the river when the river comes. Hey, what if we need collection? Yes, we need collections, definitely. That we will discuss when we're doing with EF core. If we start in the section 2 itself, if we start discussing about C# and doing these deep dives into intermediate language and where the compiler is generating in the top level statements and what is collections, what is object-oriented programming, our entire life will go in section 2. So think of crossing the river when the river comes and just enough knowledge for us to walk and then just enough knowledge for us to run. So we'll come and learn about that. So some of the things which are there, which we will learn while we are discussing on EF core. Like if you see, I can cap it the C# to 6 hours. So 6 3s are 18. We can quickly complete that. And then we will stand up a minimal API with EF core and in-memory database, Swagger included, get all and get by ID. And then we'll write the .NET console client. Now we'll discuss about HTTP client factory and a little bit of best practices when you're writing the clients, how do you need to write. Then we'll discuss about monolith versus microservice architecture. And also we'll discuss about all-in-one versus layered architecture. And one question sometimes even I think, it's not that others are thinking about this. Sometimes I also think this. Is layer architecture better than hexagonal architecture, or is clean architecture better than hexagonal? Like these kind of things people will ask, and even that includes me. I'm not telling that I never asked that question. I ask if I speak with someone else, say that, hey, which one is better? Which one should I use? See, it all depends upon what goes in your team composition, the tech skills, and understanding, and the length of project, who's using. A lot of attributes will come. So we'll not jump into that. But simple thing I'm telling that you need to cut a tomato. So you can cut a tomato with a kitchen knife or the chainsaw. Okay, it's like that. The architecture is like that. So you keep a tomato on the kitchen and get the chainsaw and cut it. You might cut your hand along with the tomato, or it will cut the extra board. You don't know. The right tool for the right job. That comes with experience. And another thing is you need to do a tech feasibility study before deciding whether can I choose A or B, the complexity, the domain, a lot of things are there. We'll come and discuss about that. So, and we'll do just enough Azure crash course so that we created a minimal API. How can I go and deploy that? Then we'll do a mini project. Is that we'll go and deploy the minimal API to Azure. The next one is we'll write a simple static HTML, CSS, and JavaScript website, and that will integrate. We'll do a fetch and get the data and write the TR tag to write it to the HTML. Then let's learn something about the server side application. If you compare with this architectural diagram, so this minimal API with some data store. Right now it is assume that it is in memory, or it could be SQLite or SQL Server or MySQL, Postgres, Azure Cosmos, or MongoDB, whatever it is, one microservice. So after this one microservice, we'll create a Spark kind of thing. I'm not categorizing that HTML, CSS, JavaScript. I'm putting it here somewhere here. It's a static website with getting the information, making itself a dynamic between these two connections. Like that, we'll spend small sprints, learn some topic, and what is the use of this, then deploy it to Azure. And then we'll come back real quick here to create a server-side application. We can, if we need to deal with the legacy systems or legacy code, we'll worry about MVC and Razors. So we'll choose Razor. And then we'll learn about that and we'll deploy that Razor with minimal API. Now itself, you see that you know what is C#, what is object-oriented programming, what is EF core, how do you create minimal API, how do you create .NET client speaking to the minimal API, and a little bit of monolith versus microservice architecture, and a little bit of Azure, and how do you deploy the minimal API to Azure, and how do you integrate that with the static API, and the server-side application. We are choosing Razor pages, and then we'll integrate the Razor pages with the minimal API and then do another deployment. And then right now the minimal API is using the in-memory. Now do you create the SQL Server project and deploy it to Azure, and then do an update to the minimal API, which speaks to the database. And all these things is being done in the mono repo. That means there's a single repository where you have a API, where you have web, and where you have database. All these three projects within the same solution. Then we'll speak about the There's nothing problem. I mean, we can go ahead and create. If it is working good, it is working good. So the same solution is getting modified. So we'll see the benefit. What if the minimal API goes into its own repository and the database project goes into its own repository and the Razor Pages goes into its own repository. So each of them having their own repository and they have their own build pipelines, their own release cycles, their own test cases, like separation of concerns, each having that. So like that, we'll slowly come into the automated deployment using GitHub Actions. But the resources are being created manually, but we will use the GitHub pipeline to do a CI/CD. Then we'll come and learn about the cache aside pattern. Do we need to go and hit the database all the time? It could be based on the data. Imagine a scenario where you're storing the gold prices, assuming that the gold price changes every 24 hours. So every 24 hours, you are to do this a maintenance job of seeing the gold price, what it was yesterday and what it's now. Is it stale? If it is stale, you need to do a cache busting and reload the cache. Imagine a scenario you're storing the stock prices in cache. That's a purely overkill. The stock prices change every second. Every now and then it changes. It might bring down the entire solution. Imagine a scenario you're storing professors of a college in a cache. It makes sense. Within a year, how many times a professor's data will change, whether he's getting a raise in his paycheck or whether he's getting promoted or whether his personal address is changing? Very rarely. It makes sense to store those kind of data. And it also makes sense to improve the performance. To get this data, we don't need to go and hit the database all the time. You can go get and store it in the cache. And anytime the professor's information gets modified in the database, you can do invalidate the cache and reload the cache. And then we'll learn a little bit of solid principles, not exactly focusing that entire 10 hours or 5 hours on solid principles. We'll just introduce, but along with other topics, we'll do like a bonus episode. Assume that we are doing 1 hour session. So 15 minutes, 45 minutes, we'll discuss this. Or last 15 minutes or 10 minutes, we can discuss about one principle in solid, like that. I mean, we'll do a mix and match. So we'll discuss about just enough AWS. And how do you deploy the minimal API in AWS? We did it in Azure. Now we'll do it in AWS. And then we'll use another mini project. Like this, we'll have GitHub Actions. I'll quickly walk you through, like PowerShell, Azure CLI. We use Cloud Shell, curl and Postman, and data access using ADO.NET, data access using Dapper, data access using EF Core. We already learned it. Like how do we do web API? So the minimal API is endpoints where you have a lesser infrastructure, full-blown controller web API where you have the controllers that we use another two sets of data stores. And then guys, someone is using the Mixie for juice or something, but even I need a glass of juice for sure. Jokes apart. So then we'll come and do this web API deployment, and then we'll speak about the all-in-one architecture, and then we'll speak about the layered architecture. So we'll create this minimal API and web API in all-in-one architecture. That means within the solution itself, within the project itself, we'll have different folders and different files will get moved into that. Like entities in DTOs will go into data folder, and DP context goes into the persistence folder, migrations if it is applicable, like application core. And then we'll create few libraries and move these files from the folders into those libraries and see the advantage and see the differences between all-in-one and layered architecture. And going one level further is, what if I create the NuGet package of these, then our minimal API and web API will become much leaner and thin because those libraries have been moved to a centralized location. All we have to do is add the reference of those NuGet packages. So step-by-step approach, like all-in-one, layered, libraries, like this, we will go step by step. And we should know that where should we stop. Just that we learn layered architecture and we start applying layered architecture in every project. As I was mentioning, you're using a chainsaw to cut a tomato. That might do it more damage than helping you. So you need to know that where to stop. But you're learning, we will learn together all these techniques. Okay. So then we'll start learning a little bit of data structures and algorithms. Why do we need to learn this data structures and algorithms? We're not writing any operating systems or doing anything of those high kind of things. So what we have to do is, until unless you know the kind of data structure you need to take to store the data, it might be overkill if you're not choosing the correct data structure. Instead of solving a problem, you're creating a problem for yourself. And regarding the algorithm, until unless you know the right data structure and right way to compute it, we might not be doing the good job. We are doing the job, but efficient. So if something which can be done in less number of lines, in less operations, than something which we have to write more lines because of our algorithm. Okay. And then we will do microservices and we'll learn about Blazor and how do you do the Blazor server deployment to Azure and AWS, and how do you do, these are manual, and how do you do with the automated. And then we'll do a little bit of Linux and shell scripting. And definitely you see that anytime you go, everywhere you will have, now see this, what is git bash? It executes all the Linux commands. See that? It's all executing the Linux commands everywhere. Now you have WSL, and most of the places we go and use it, apart from Windows, whether you use Linux or Mac OS, you definitely need the skill set of shell scripting. We will learn that. And a little bit of little bit of biceps and Blazor WebAssembly, Terraform, .NET MOI. So trying to create these kind of a big solution end to end, but we'll start very slow and we'll go step by step. Not exactly, we might be dealing with the eShop, or we might be doing some mini project using something, some mini project using something, some mini project using some other, like movie tickets or traditional student school kind of thing, or some other domain, like a gaming domain or some other domain. We'll pick up different domains, experiment different data stores, and learn something. And at the end, we can do a major full-blown solution. Because see this, by doing the mini project, you are keeping it ready. We should be able to switch and go ahead. Like we learned Angular 16, which released a couple of months ago, and advanced data retrieval, paging, filtering, searching, and sorting, and React, Vue.js. Like if you see HTML, JavaScript, CSS, Razor Pages, server side, Blazor server, the server side, Blazor WebAssembly, the SPA, Angular 16 or 17 or 18. Angular 16 is the latest one. That's SPA, React.js, SPA, and Vue.js, SPA. So we are touching a different technologies like SPA versus mobile, MOI, and the SPA applications. And we'll learn something about the real-time SignalR, Docker Compose, and we'll create our own identity system, IDEN server. Okay, identity server, little bit of gRPC, design patterns, OData, GraphQL, background services. How do you, now you have bunch of services, how do you communicate between those services? Do you need to do a synchronous communication, or do you need to do asynchronous communication using enterprise service bus, Kafka or RabbitMQ or service bus, or just simple storage queues? Suppose if you're retrieving the menu items of a small hotel, idli, dosha, puri, and their prices. Now, hotel microservice is going and getting the prices from the centralized head office of that restaurant chain. Now, the service to service communication is happening. Can I use Kafka? I learned this latest technology. Let's use Kafka. That might be an overkill. Imagine a scenario, the service A drops a request saying that, hey, give me the price of today's menu items. And it goes to the Kafka. And other service which has to watch this, either pull or push mechanism, whatever the mechanism you use it, you need retrieve it and go speak to the database and come and drop the data here in this queue again. And this guy will pick it up. Until this is happening, I know that even though it takes few milliseconds, until this entire chain of actions happen, the UI will be spinner. Please wait while we're loading. And user he will say that I'm fine dying out of the hunger. I don't need this idli or dosha from this restaurant, isn't it? That's an overkill. Now it's better to do a synchronous communication from service A to service B. Hey, give me the prices. If it gives okay, I'll display on the screen. If it is not, I'll say that some 500 exception has happened. Please refresh the button. That's much faster, isn't it? Fail fast. Imagine a scenario, it takes 5 seconds and it fails versus it takes 1 second and it fails. I would love seeing the 1 second failure because I know that I need to click refresh. Maybe next time it is clearing. So within 3 seconds, I'm getting the output. In another case where we are using the asynchronous communication, it is taking 5 seconds and it is blowing off. So these all we need to try and think. Do I need a kitchen knife or do I need a chainsaw? Okay, we'll do that. And resiliency and timeouts. Imagine a scenario where you got wait and retry and when you should retry. Suppose if you're getting 401, does it make sense to retry? Unauthorized. Someone is trying to hack into our system. Is not sending the right token or is he fiddle with the existing token and is trying to hit it. We should not allow. No need to do a resiliency timeouts or retries in this mechanism. It doesn't make sense. Then we'll come and see about the nano service. And then creating the web APIs in different technologies. Because by this time we will have enough appetite to go ahead and try different programming languages. See, I'll show you one simple thing. Previously there used to be a lot difference between different programming languages. Now, if you see that .NET, I'll show you this one, and we'll compare There you go. With these 3 lines, you are able to create a web API. It starts just these 3 lines. Now let's come and see that simple web API in Node.js. A very, very simple web API in Node.js. That's when I place this side by side. What is the difference? It's almost same. See this app.mapGet versus app.get. So it has got the route and it has got the Lambda function. And you're saying run, here you're saying listen. That's it. And these 2 lines, here we can consider the app express and we are specifying the port. The port we can push it to the .env file. And here we are not using statements here because it's having the implicit using. That means if I come back to, oh, Jesus. Okay, here. If you come and see that, that has got implicit usings. It will have an implicit using. I'll see this. It has got an implicit using. So when you have the implicit using, what will happen is all the usings which are needed will be put into one file that's called the global using. These all are getting implicitly imported into your file. So you don't need to specify explicitly using this, using this, using this. Like here we specified that using system. Here in this, you don't need. So that's one difference. But apart from that, you don't see any major difference between creating a web API in .NET or creating a web API in the Node.js. Or a matter of fact, the Golang will be a little bit different and the Java is a little different. And Python, okay, fast API or whatever the framework. But definitely by the time you come here, you don't find any tough or differences between this one. I mean, the framework is different. There are nuts and bolts which we need to know. And nowadays, each of these languages are very, very competitive. It's like a cutthroat competition between this. And we will definitely have to touch at least, because when we are speaking about the microservice, it makes sense to try different things. Like we'll try a bit of Node.js, Java, Spring, and Flask, Golang. And definitely we are working in a polyglot data store. In-memory, SQLite, SQL Server, Redis, Cosmos DB, MySQL, Postgres, Mongo, DynamoDB, Firebase, and H2. We might use something else also. I'm not sure at this point of time. Then we use the asynchronous communication, the Kubernetes, little bit of data analytics, AI/ML. Alerts and monitorings are very, very important. The observability, like Prometheus or API gateways, a lot of other things I didn't put it here because now itself it's going unrealistic. So we might do an individual POCs like doing a small web API or something in domain-driven design, something in CQRS, something in event-driven architectures like microservice, nano service. We'll try different combinations. So that is my goal. And this is the organization which have put it. I just created only 9 repositories. And as and when we grow old, this is for the first mini project. MP1, all the MPs with numeric is like a mini projects. So this is my idea, goal, or vision, or my personal project for next 3 years. I'm going to create because I just started since 2 months. I was updating the documentation of that organization. So how are you guys feeling on this one? Is it realistic, or I'll go by the people I'm seeing in on my screen? Pawnee, anything? Is it interesting or is it unrealistic? I'll stop the recording. We can speak